Hello everyone, thank you for being at the talk. I imagine that in the year 2023, I would be driving a flying car. We would have some very fancy computing devices that can read my mind, can order me the very specific kind of coffee that I like, what have you. But instead, what we have is the famous log4j shell. She kind of stole my thunder with this slide. Uh, we also had like the SolarWinds attack. I think people might be familiar with that. And then there's a whole raft of typo squatting issues that people are all talking about. Hello everyone and welcome to my talk on securing open source supply chains. My name is Ram Iyengar. I am the Chief Evangelist at the Cloud Foundry Foundation. What that means is I work with a lot of the community members, making sure that the community is active and engaged and help with a lot of the governance stuff around the open source Cloud Foundry project. But what I also have is code side seats to have a look at what an open source project is in reality, how it is adopted by the community, what are the difficulties during adoption. And one of the areas that we've invested a lot of time and effort in, and we plan to invest a lot of time and effort in the coming weeks and months, is this area of supply chain security. Now, I imagine that a lot of people will be in a similar, if not the same position, which is I come from a background that is not in security. I come from a background that's in application development. I have been going through the whole process of creating immutable jar files about 10, 12 years ago to going through containers, and then now obviously being a part of Kubernetes and fancy container orchestration and things like that. And I imagine that there's probably a lot of people who are in a similar situation where there's not enough awareness about what is causing these issues. And in particular, if you're in the business of consuming or contributing to open source software, there's not enough awareness about how your actions can impact the security of those who are consuming your projects. And so that's what led me to this, to creating this talk. And the reason it's very important right now is it threatens the very fabric of what it means to be open source. I'm sure everybody here has either consumed some sort of open source projects or have contributed to some sort of open source projects, and this notion of supply chain security is extremely important to this open source community because we create open source projects with the intent of those being trusted and consumed, whereas all of these attacks that we are looking at are aimed at destroying that very paradigm that is the basis of this entire community. And there's a lot of research that's obviously going into understanding what the issue is, educating people about what the issues are, and things like that. And so in this talk, I'm going to go over a few things that will obviously help in educating you, but a little bit of entertainment as well. So let's begin with the fundamental question of what a software supply chain is. It's built to mimic a regular quote unquote supply chain. So it's a description of many composite elements that come together and make a whole. For example, if you have to buy a laptop, you require a lot of components to come together at the manufacturer's level, be built into a finished laptop, and have that shipped to you, and you consume that end product in the form of a device. A software supply chain is no different. So I'm sure like all of you here make use of components that you haven't written. It might be something as simple as an email tool, a phone, or it might be something that you've written on your own. So there's a composite nature in terms of the different pieces of software and the different pieces of digital goods that you make use of. And so all of these are pieced together from different components that are sourced from different places. And so that is what the software or the digital supply chain is. Now moving on to what's software supply chain security. Now, it's obviously the science of securing these open source components, or all of these components that come together to form the secure piece of, or the secure artifacts that you intend to use. There was a time long, long ago when there was dev and there was ops. There's probably people in this room who don't even remember that. Eventually, it all became sort of DevOps, where people said that you need to take responsibility of what you're putting into production. You just can't toss it over the wall, etc., etc. And then they decided to fuse these together. I'm not here to comment about whether that's good, whether that's bad, etc., etc. But it is what it is. And then eventually things started to become slightly more complex. A lot of issues started to seep through, particularly regarding security. And then we have this notion of DevSecOps, which has been a thing, right? And then if you think about it, developers are being tasked with so much more than just development and just ops, and eventually it's going to lead to something I can't mention on stage, okay? And so that's the idea that we are fighting here. So there is this notion of software that's being written and that's being consumed in so many layers ahead of you. So this particular image that I have here highlights a very basic flow about there's source code that you write, there's artifacts that you might consume in the form of dependencies or libraries or other things, and then together all of that gets built into, today it's built into a container image, right? That container image goes into a container registry, or if you're more fancy, an artifact registry, where it will live to either be deployed, to be consumed as a piece of software, or it will form other dependencies that will be used downstream. And so this is a very basic structure of that software supply chain that we are talking about. And now securing this entire sort of spread of digital artifacts is what forms the notion of software supply chain security. Now, why it has become something very interesting is not just because of those stories that I was talking about a few minutes ago, but there's also a big sort of push from governments. So the US government issued an order. They call it an executive order signed by the president. So the president. So the current administration signed this order about 18-20 months ago, and this basically specifies very clearly about software supply chains and the need for securing supply chains and sub chains, and the need for making sure that critical infrastructure that is made use of ensures that people know what's inside the software that's being run. Not the people who consume it, but the people who are not, I mean, it doesn't have to be that people who consume it don't have to know about it, but the people who are building it definitely have to know about it. That's the core of this. The EU also is mulling a thing called the CRA, Cyber Resilience Act, and they have they're close to adopting this measure of how they want security and supply chain security and what they need to know in terms of what's going inside a container, things like that, right? India doesn't have anything yet, so we don't have very strict rules or something stringent about following something that requires transparency, that requires to prove provenance. This is not meant as a derision of the state of the technology that we are in, but I think it's an opportunity for us to come forward and start to contribute in terms of, here's the idea of a policy that can make infrastructure, that can make artifacts, that can make digital tools that we have more secure. There's definitely a big push for digital in the country. We see it on hoardings, we see it in the newspapers, we see it being talked about everywhere. But at the same time, securing this digital India is also a matter of policy and implementation, and I think this is an opportunity to come forward and start contributing towards that policy and not just doing things in retrospect later. Now, I'm going to dive in a little bit into the details about a couple of stories. Okay, you can sit back, relax. I know it's getting close to lunch, and a story is the most interesting form of communicating these things. The SolarWinds attack that happened, and this is the exact digital asset that was compromised. So, are people aware of the story, or shall I go into a little detail? Yes, no? Yes, good. So the SolarWinds attack happened a few, almost 18, 20, 24 months ago. And it's a story about how there has been systemic failure in terms of being able to recognize what is wrong and not being able to gain that kind of transparency that's required in order to actually secure the digital artifacts that are in production in your systems right now. So what happened was there's a tool called Orion, which is used for network monitoring, and Orion was sold commercially by SolarWinds. So SolarWinds is the name of the company that actually developed and marketed this software known as Orion. One of the components inside Orion was this DLL file that was compromised. So they had this DLL file, it was compromised. They shipped the Orion network management software with a copy of this malicious DLL file, and this was then installed on a lot of servers in a lot of important places, including the US military, the Pentagon, a lot of universities and things like that. One of Orion's customers is a cybersecurity firm. Okay, so wrong place for malicious code to live, but even they let it run for months before they actually detected it. So there was a cybersecurity firm who also purchased Orion software, and after a few weeks of using the software, they realized that there's something in their production, running in their stack, that was not supposed to be there. So they were not able to find a log of this particular file being modified when it said it was. Inside this piece of malicious code was a backdoor that wasn't activated for a few weeks after everybody had installed this, and then a few weeks later it started to send a lot of files, it started to send a lot of data back to like a group of Russian hackers who had placed it there. After acquiring all of those files, they started to send emails about ransom. So they started contacting users of Orion software directly and saying, if you pay a sufficient amount of money, we'll shut this backdoor. And that's typically how they operate. Now this cybersecurity firm who we are talking about, they actually found out about this, and then they codenamed this whole thing called Sunburst. So they had a project called Sunburst, and then Sunburst was the fix to this particular DLL file, which was then rolled out in a matter of a short period, and then people were actually relieved of this particular broken DLL file. So that's the Sunburst, that's the SolarWinds story in a gist. I can do another story if people are interested. So this one is slightly older. This is 5 years old. Okay. Has anybody heard of, does anybody use NPM here, like Node.js, NPM folks? Right. Don't be proud of it. So this is an NPM package. Okay. It's quite popular. So the use of cross-env was basically for storing environment variables and then sharing them across different places and things like that. And as you know, environment variables can be pretty critical. Now one person had the genius idea of creating another NPM package named cross-env. It's very difficult to tell the difference, right? And obviously people started to download this instead of that. They went to Stack Overflow, they saw an answer that they like, copy, paste, ship, deploy, go off, have fun, have coffee, whatever, right? So people started to use the wrong, this is the wrong one by the way, people started to use the wrong NPM package inside their code, and that started to give problems downstream because this particular package allowed access to environment variables across a large swathe of code. All of the information there was shipped back to the person who wrote this, and then they were able to get access into the systems. And then the problem with getting access into systems right now is, as an example, there's GitHub, okay? And GitHub has access to users of GitHub here. Don't be ashamed, I won't make fun anymore, right? People using GitHub, right? So I'm a GitHub user myself. So my source code is on GitHub, right? And then we now have GitHub Actions that allows basic CI/CD, does a lot of automation. People have GitHub Actions deploy to production. Anyone? Anyone? Yeah, good. So people have GitHub Actions deployed to production. So GitHub Actions then has access to a lot of your staging systems as well, your production systems and things like that. And so imagine if your GitHub keys are somewhere in your environment variables, and then now somebody has access to your environment variables, which means they have access to your GitHub. And so getting access to GitHub can create a problem because it has access end to end of all of the different pieces that take your source code and put them into production. So your entire platform is sort of compromised just through environment variables. And so that's the kind of problem that we are talking about. Now I'll shift gears, and in the second half of this presentation, let's take a slightly deep look into how can we counter some of these attacks. Now, as developers, like I said, you have a lot to do already, but now it's an opportunity to be educated in some of these security practices. The good thing is there's a lot of work that has gone into simplifying this for developers, but then obviously it's a little extra work and nobody likes that. I don't, and I'm sure there's a lot of people like me. So let's take a look at three different things. So I'm going to talk about SIG-Store, which is signing a lot of your artifacts. I'm going to showcase something called SLSA. I know it's close to lunch. I shouldn't be saying food related stuff. So I'm going to focus on SLSA, which is another project. And then finally, we're going to take a look at SBOMs. So what ties these together are, these are all simple ways, preferably without a lot of cognitive overhead, without a lot of overhead for the developer, in order to make their open source components more secure. And what ties all of these together is the OpenSSF, which is an independent body that's working towards making software better and more secure. And all of these are projects that are owned by the OpenSSF. OpenSSF in turn is a part of the Linux Foundation. So we'll take a look at all of this in this second part. Countering these, like I said, is a combination of both tools and techniques. Now, what I should add is a combination of good tools and properly implemented techniques. I will take a look at the first one called SLSA. So SLSA stands for Supply Chain Levels for Software Artifacts. Now this is very specific to supply chain security. The others not so much, but they have more application here. So this particular thing called SLSA originated, like a lot of projects that we tend to talk about, originated at Google. So they had a way in which developers had to go through a process of making sure that the different digital artifacts that are produced are actually traceable, and they have a term for that called provenance. So provenance means being able to prove exactly where this artifact came from and who did it and what it was done for, etc., etc. SLSA has levels. We'll get into that, but just to sort of put an understanding into a little more understanding into how the process of software development is actually defined. Very quickly, there's a developer. Developers have source code on their machines. They check that into version control. Hopefully everybody here does that. Obviously you do. You all raised your hands for GitHub. And then once it's in version control, builds happen. And builds pull in dependencies in other forms. And then there's deployments. Deployments might happen to like staging instances, to production, pre-production, some quality assurance instances that you're using, etc. And some of these are pushed back as dependencies, what have you, and then users actually consume this software, or in some cases the usage itself is as dependencies like we've discussed. So SLSA or practitioners of SLSA define two areas in this process. So they split it as source integrity and build integrity. How do I know that the code that you've written and committed is actually coming from you? So obviously when you do a check-in into GitHub and things like that, you have git commit stuff, and the larger question that they raise is the git commit that you did should not have a malicious intent. Like we just saw, it's possible to get access to git credentials of other people, and so how do you counter that? And then there's the build integrity process that we spoke about, where people want to know if the dependencies that you're pulling in are right, the build process itself is happening in a sanitized environment, and so on. And the bad news is they define a lot of attack vectors in pretty much every single space of this entire simple workflow that we all go through hundreds of times a week, right? And what complicates this is there's so many developers out there working on their own branches and trunks and what have you, and all of this has to come together securely, right? So in order to do this, SLSA prescribes certain levels. They have prescribed levels for the dev process, they have prescribed levels for the build process, they have prescribed levels for the deployment process, etc. And we'll take a look very quickly at what the build process is like and what the splits are for SLSA. Right, so this is a matrix that I'll just fill in the next few slides, and that will give you an idea of what the different SLSA levels are for the software build process itself. So level 1 is very, very basic. It has a prescriptive notion for how a build should be. For example, it should be automated. Oh, Rahul didn't come to office today, we can't do a build. That should not be the case. You should have a script, that script should be somewhere central, and one of the descriptions, which is probably the most difficult here, is the build process should be documented, right? How many of you have documented build process? Don't raise your hands. This is more of an internal retrospective question, right? If you don't, shame on you, okay? So that those are very basic sanity checks for a good build process. And then it builds onto a level 2. In level 2, you need to have a way in which you're retaining information about software components. The build process itself is a build service, not a build workflow that you execute from your machine, right? It's a build service that's happening somewhere, and you invoke that build service by giving them access to your source code. So here's my trunk, go build it, and not build the container on your machine and say, let's ship these images or these layers, right? So the build should happen as a service external to an individual's device. A level 3 is a slightly more involved level. Provenance is a requirement, like you need to know who triggered the build, what machines these were built on, etc. And the artifacts should come with provenance records that are very important. They also need to have a notion of build environments that are isolated from other environments, so the build environment itself is not a part of some other system that is used for, let's say, running some other workloads, etc. So you need to have sufficient isolation for your build processes to be able to run effectively. And then the final requirements are like a level 4, where they have parameterless builds, which is when you trigger a build, you don't supply unnecessary parameters to it. So a build should be very automated, turn of a button kind of thing, instead of you configure this complex set of parameters that go in, and the build process is a non-repeatable one and things like that. The last thing is hermetic builds. So hermetic means sealed, right? So if your builds happen on environments that cannot be affected or cannot be compromised through other means, that is a more sustained way according to SLSA. There's obviously a lot of details in terms of what that is, but these are a set of different ways in which you can ensure that what you're building is actually what you're building. So making sure that it's isolated enough, it's not flaky, and you have a repeatable and a sealed build process. Let's move on slightly quickly for paucity of time, among other things. There's a project called Sigstore. Have folks heard about it? Anybody? Sigstore? Yeah, good. Nice show of hands. So it's basically the notion of signed artifacts. I'll move through. I think I have a simple set of slides. No, I don't. So Sigstore is again divided into a number of components, and one of the example flows that I'm going to show here has 3 stages. So the first stage is using a project known as FullCO in order to generate a certificate, and that certificate is something that makes use of your identity in order to generate the provenance that is required in order to sign a particular build, let's say. The second part of this process advocates the use of a project known as Recore. Recore is a transparency log. It helps folks audit what they're going to build and what they're going to push. The third part of this is Cosign. So Cosign is a project. Cosign is the more popular one that people have heard of, I think. Okay, Cosign is a part of the Sigstore, and it does the part that basically allows you to add your signature using the certificate that you invoked in stage 1 and recording all of that information in a Recore record. Okay, and all of these are a part of Sigstore. Sigstore also has a policy controller that they introduced recently, and so if you've signed something, you can create a policy on your Kubernetes clusters that basically say, if you have signed using Cosign, only then deploy these container images. So there's a fourth project there that can also be used. If all of this sounds a little complicated, and I'm sure it is, I think there's a more popular project. Folks heard of TEKTON? Yes, show of hands. Don't want you to get sleepy. Yes. So TEKTON is having a version of TEKTON chains, which is basically aimed at better supply chain security. And I said simpler, so excuse me for this slide. I will break this down though. So it's basically 3 stages. You have a task run, right, in TEKTON. Yes? Yes? Task run? Okay. So you take the output of task run and push it through 2 stages that basically allow you to add signatures, and then it will allow you to do an attestation of that signature before the deployment itself. So it's just a module that you introduce in your existing TEKTON workflows. Good thing is it integrates with the Sigstore projects, so you can pull those in if you're more familiar with it. So last few things I'm going to rush through a little bit here. So I have a terminal window. What's a developer conference without like a small terminal for the demo, right? So this is something that I'm using in order to generate SBOMs. Okay, so what are SBOMs? SBOMs are software bill of materials. They basically mimic, this is also a supply chain concept. So bill of materials is basically a whole list of the things that go into building a bigger component, right? So these are all the materials that are inside a car. So a software bill of materials actually gives us insight into what that is. And so I'm going to quickly show you here that SBOMs are generated in different formats. There's a big formats war going on, obviously, for all good things. And so there's different formats in which you can see SBOMs, but you can get into any of these and it will basically show you what's inside the image and things like that. I have a minute to go. So the OpenSSF, it's an independent sort of organization that is built to make open source software more secure. Obviously their focus for now is set on supply chain security, among other things. Their goal is to produce high quality software, right, which they're calling that's performant, that's also secure. It's a forum for people to easily discuss both technology and policy, and it's a place where the community can come and make sure that any vulnerability information that they report is transmitted across the supply chain and things like that. So that's my talk. Hopefully you learned a thing or two. Thank you for being a wonderful audience, and thank you KCD Bangalore for having me.